I'm Josh Long.
And I'm Mark Heckler.
Mark, I'm not getting any younger. I've got gray hairs, things hurt. I wake up every morning like a baby giraffe.
How so? Growing to meet the brand new day? Or stretching and growing to rise above things? Or excited for new heights and horizons?
No, wobbly, disoriented, blind, and slow.
Sounds like you might just need some stronger coffee.
Because I'm getting older, I just don't have the time for handcrafted, artisanal paths to production. I want to get there as quickly as possible, and I find it irritating to be ever so close, yet so far.
Well, what do you think about using Kubernetes?
Have you ever seen that show, Naked and Afraid, where two people are dropped naked into the wild and forced to survive entirely off the land for 21 days with nothing but their wits and a machete or a fire starter?
Yeah.
Well, Kubernetes is all machetes all the time. It's just sharp edges. You don't even get a fire starter.
Although there are plenty of fires.
Look, I love Kubernetes, but I'll be the first to say that it's not a particularly productive out-of-the-gate story. It's not a platform. It's a foundational layer on top of which to build a platform. I don't think anybody would argue that it is the easiest, most optimized path to production. Kelsey certainly doesn't. And to my mind, platforms should be optimized for the 80% case.
So what is the typical use case?
Well, it's obvious that it
help people find that perfect cup of Java?
No, but I take your point. My 80% case may not be your 80% case. So the ideal platform should be optimized for the 80% case, but support the exceptions as necessary.
You can't have everything, Josh. Don't be greedy. Remember that time when you tried to run Slack and Emacs and do a Scala build at the same time?
There are some very productive application platforms out there like Azure Spring Cloud, Knative, and Cloud Foundry that sit on top of Kubernetes. So we won't retread that path today. Instead, we're going to look at how to write software that doesn't just run on top of Kubernetes, oblivious to its surroundings, but that responds to and extends Kubernetes. We're going to look at ways that we can write more elegant cloud-native software with Spring and Kubernetes.
Sounds good to me. That should be a lot of fun. There are a ton of interesting things a Spring application can do in Kubernetes that it couldn't do nearly so easily otherwise. The Spring ecosystem is flush with Kubernetes integrations. Too many even. We'll need some help.
Absolutely. Good thing that our friends have agreed to help us today. We'll be joined by
Tiffany Jernigan, who eats production fires for breakfast.
Mario Gray, the original full-stack developer and fellow Spring developer advocate.
Chris Sterling, Spring Cloud Services Guru and lead of Spring Cloud for Kubernetes.
Dave Turanski, a major contributor to all things messaging and integration on the Spring team.
And Nate Schutta, an architect who truly, truly wants to help.
And our special guest star, Joe Beda, a co-founder of the Kubernetes project.
To quote the Ninth Doctor, fantastic. We're going to need a domain for our demo, though, something that speaks to us, something that brings out the best of us, that inspires our better angels, something that is our constant companion, even in the darkest of times.
Our families?
No, coffee.
Oh, right. All right, good point. Let's get started. First, a bit of housekeeping. Today we're going to look at a lot of different modules. So to make it easier to follow, we're going to use icons to indicate on which modules a given presenter will operate. We're going to look at a shopping cart that manages the inventory and orders for coffee, a Kubernetes controller that interacts with the controller API, a point service that manages loyalty rewards associated with each account, the Spring Cloud Dataflow stream that calculates the rewards associated with a given account, an API gateway that fronts requests to our downstream APIs. When we introduce a section, we'll highlight the icons corresponding to each module. This will act as a sort of "you are here" marker on the map of the architecture that we're building. Hey there, it's me again, Josh Long. I'm up at bat first, and I'm going to get things rolling with some functional, if not naive, code that manages data associated with a coffee shop and the loyalty points for that coffee shop. Is this code ready for production in Kubernetes? Not hardly. Let's take a look. Hi, Spring fans. You know, I just want to get software into production. If you know me, then you know I love production. I love seeing software delivered to the hands of the users that can use it and hopefully where it'll delight them. But that is obviously not as easy as it sounds. There are a lot of things you need to care for, and that's okay because there are some, with a corresponding sort of increase in complexity comes an increase in opportunity. And one place where I see that so often these days is Kubernetes. Kubernetes is a foundational platform on top of which you can build really amazing things. And so we're going to write a very simple application. We're going to build a coffee shop sort of domain, and we're going to deliver that into production. There's obviously a lot of things to do, a lot of things to learn, but software is a team sport, and I'm going to lean on my friends today to help us get from here, from concept all the way to customer. Let's get to the code. All right, we have to build two different things. First, a cart service to represent the catalog of coffee and the ability to make orders for that coffee. Let's go to start.spring.io, my second favorite place on the internet after production. We'll build a new service with a group ID of Booternetes.cafe, and the application ID will be cart. We're going to add some dependencies, the reactive web support, the Postgres reactive SQL database driver, the Lombok compile time annotation processor, the Spring Boot actuator, and the Spring Cloud Commons. So Spring Cloud. We're also going to add R2DBC, which is a reactive relational database connectivity abstraction, and then we'll hit generate. Our service is going to manage two types of entities. The first of which is a coffee. It's the kind of coffee that's on order, so we'll give it a primary key for the ID and some usual fields. We want to be able to map the ID to a primary key in the database, so we use Spring Data's ID annotation. And of course, we want some getters and some setters and so constructors and toString and all that. We use table, cafe. Okay. We're going to need to manage order data associated with orders for the coffee. And same thing as before, getters, setters, toString, and an annotation to map it to orders in our SQL database. We're going to need a repository to manage instances of this data. And we're going to need a REST API to surface the coffee catalog itself. We need a constructor, so we'll synthesize that with the required args constructor. And now we want a endpoint to manage orders from the cart or for the cart. So let's create a new REST controller. This order service is going to publish an event to the Spring Cloud Dataflow source, which will then do some calculations and then eventually update the point service, the loyalty point service, the reward service. So we need to inject the configuration value for that URL. So private final string cart points. We're also going to need a few other things to do our work. We're going to need a coffee repository, the order repository, and a web client to make that call to the Dataflow service. Now we need a constructor for this. And the only tricky bit is that we need to make sure we inject the configuration here, cart.points, let's say sync URL. And there we are. There's our constructor. Now we can actually build up these endpoints that will support what we're trying to do. given a post to the cart orders endpoint, we'll be able to place an order. I want to log out each order that's been saved. And then return just an empty mono. Now, while each order gets saved, we then want to publish the event to Spring Cloud Dataflow. So I'm going to create a method here that actually does the work of sending it. And we're going to call that endpoint from this. We're going to say flat map this send. All right, there's our order rest controller and our coffee controller. The only thing I can imagine needing at this point is just a little bit to specify, first of all, the coffees that we're going to load into the database. We need to connect to the database. We need to initialize some schema, that kind of stuff. So let's add a customizer, a connection factory initializer to initialize the application. Now, sadly, this stuff isn't automatically handled as it is for JDBC out of the box. You have to actually do this work yourself, but it is coming in the new version of Spring Boot. And in the meantime, it's not that big a deal. Schema.sql. Data.sql. Now we don't actually have anything we want to put in data.sql, but it's just nice to know that you could. So what we need now is a initializer. We're going to inject the connection factory here. Okay, we've got our connection factory initializer. We're also going to need to make an HTTP call to the Spring Cloud Dataflow endpoint. So we're going to factory a non-blocking web client, HTTP web client. Okay, we've got everything we need. I think the only thing now is, how do we actually connect? What does the connection to our application look like, our database look like? So we're going to specify that as some properties. The first property, of course, is the list of coffees. So we're going to put in some sample coffees in here just to get things going. We're going to need to specify that URL for the sink. We're also going to need to connect to a database. I've just done something that is completely contrary to all good security practice. I'm going to hard code a username and password. Obviously, you should use a Kubernetes config secret, but for our purposes, this will get us across the finish line. Now, this is all invariant. This will be loaded no matter who is running or where it's running it, but I also want to have some configuration that's active only when certain profiles are active or when a certain environment is detected. And in Spring Boot, we can now do that all in the same file, the same property file. It's always been possible to do that in different YAML files, but now you can do it in the same property file. So we just need to say dash, and now we can specify the activation criteria. And the default profile is a special sort of pseudo profile that is active when no other profile is active. Okay, so it's great for local development, that kind of thing. We also want to activate certain config only when the application is on Kubernetes. Here, we're going to use a more, a more parameterized, more secure URL. We're going to use some environment variables that have been set up for us in that environment as well. And of course, you can refer to the GitHub repository for the full pipeline, the full Kubernetes description and deployment. We do need to specify for later, we're going to need a bootstrap.properties. And here we're going to give our application a name of just cart. And the other thing we want to specify is the schema, in case that hasn't already been initialized. And the data. There's nothing in the data, but we do need to initialize the schema. All right, there's our schema for the two tables, cafe and cafe orders. I won't type that all out live. There's no need. But you can see it's just a pretty trivial table. Okay, we've got our schema. We've got a schema for Postgres. I've got Postgres running in a Docker image in the background here. Obviously in production, we'll deploy a real one. Let's go ahead and run this application. Okay, the application's up. Go to the command line, and I want to log into the SQL database to make sure we have some data. We need some data, so we're going to insert it. Confirmed. Now we should be able to get that data from the API. There it is. Good, so that's working. We've got the cart service. Now let's turn our eye to the point service, the membership reward point service. So we'll return again to start.spring.io. Here we're going to create a new service with the group ID of Booternetes and the artifact ID of points. And we're just going to bring in Lombok and their reactive web support. Our point service is going to manage the points associated with each user after the calculation has determined how many points they should have for each order. The point service, for our simple demo, will just be an in-memory map of data. So we'll create a service. Let's see, we want to create the map of data for a given username and some amount of points. So we'll say return map.of username points I. And we want to support retrieving that data from this in-memory map given just a username. So we'll say and what that'll do is it'll create a map of the data. It'll get the data from the map with returning the current username and the number of points that there are in the database, or 0 if there are none, right? And then we're going to use that to create an endpoint to add points. So the existing points are here. And we want to put that into the database. We want to update the database using the username as the key and updating the value. And then we want to return the points. All right, there's our points service. It seems fairly straightforward, fairly trivial. Now let's create an API that people can use to manipulate that data. We're going to read the data that will come from going to the points username endpoint. So we'll return a response entity. And here, to read the data, we'll say var points equals points service dot points for, and we'll get the username. That'll give us a map. Maybe it's better to be explicit here since it's a stringly typed map. And we're going to say if the points is not empty, we're going to return a response of OK. Oh, sorry, of. And then we're going to return, if there is no, if it is empty, then we're going to return a not found. Okay, so that's the reads. Let's look at the writes. And the writes will be a payload that comes as a post, a JSON post. And that's it. All we need to do now is to specify on which host and port we want to run this. Okay, let's test it out. No data, okay. Let's now make a post to the order service. Now that we've updated it, let's go ahead and read the data. And there we go. It reflects that we've just made that right and we've got 200 records. All right. So we have a cart service and we have the point service. Obviously, these are intended for production Kubernetes. We should definitely take advantage of the Spring Boot build pack integration. So you can say maven spring-boot :build-image, and you'll get a Docker image that you can then Docker tag and Docker publish and then reference from your Kubernetes deployment YAML. We obviously have a lot to do to make sure our code is more robust. We should certainly externalize the coffees themselves, not to mention we should initialize the database to read that coffee data. And there's a missing piece between the cart service and the point service, well, where we'll need some configuration to happen. There's a missing piece between the cart service and the point service where we'll need some configuration to happen. And so we're going to take care of that as well. That's going to be a Spring Cloud Dataflow pipeline. And of course, these APIs are insecure and they're just out there in the open web. We would want to front these with an API gateway. And so we'll look at that. And of course, there's opportunities, since we're running on Kubernetes, to extend the platform to accommodate some of our more particular use cases. So we're going to look at all these in the next few sections. This is all for me. Thanks so much for watching.
Well, a bunch of us got together and had nothing better to do. And so we said, hey, let's go through. No, the reality is that inside of Google, we had this idea, of how systems could run based on some of Google's internal systems. And like I was working on Google Compute Engine at the time, and, I presented to one of our leaders and launch a VM, SSH in, see a prompt, and his answer at that point was like, okay, now what do I do? Because inside of Google, we had this whole system that got you not just to a prompt, but actually got your application deployed and running, and that was our standard. And so Kubernetes, just like so much of what we're doing across the industry, is really about what now? Okay, I got a machine, that's great. What now do I do with it? And so that sort of moment crystallized for me this need that getting people a VM wasn't enough. We have to make it usable. We have to make it so that they can actually apply it to the problem that they have, get their application up and running, and really be successful in terms of using the cloud, not just having the cloud. Kube control is what I say, but I am my last name is Beda, but everybody says Beta or Beta. And so I'm not picky about this. I know what you're talking about. I'm not going to sweat it. So I'll accept kubectl, kubectl, kubectl. I'm cool with any of them.
Our cart and our point services work, but they're hardly reliable. If anything should go wrong, anything at all, they'd collapse like a house of cards. Distributed systems become even more volatile the larger they grow, and the faster they evolve. In this segment, Mark Heckler will show us some ways to reduce those risks.
Hi, it's Mark again. Now let's take what Josh so lovingly gave us and let's add some resilience capabilities to it. Some things that allow our applications to maybe behave a little bit better and maybe even behave better when someone's not listening on the other end. So we want to have the capability for a calling application, a knocking application, to either time out, to give up and go away when no one comes to the door, or to maybe have a certain number of times that they'll try to knock before they give up and go away, or to add some capabilities to handle when inevitably no one is home. So with that, let's go to the code.
We're going to, at this point, examine what happens when things don't go as we would hope. Because in many cases, of course, they do. Josh and I have had some long conversations about this. We're using Spring Cloud Dataflow, obviously, throughout. And Spring Cloud Dataflow, sometimes we think the DF doesn't stand for Dataflow. It stands for doesn't fail. And of course, that makes things terribly inconvenient when you're trying to show what happens when things do go off the tracks. So what we wanted to do is maybe take things in a little different direction and show what happens in the ways that we can perhaps accommodate and embrace failures so that we can show some resiliency factors. So what we wanted to do is show a fail service that we've created here to indicate and to represent what can happen when things aren't going perfectly according to plan. So we have 3 endpoints here, an OK endpoint, as you might imagine, which means things are okay, right? A timeout and a retry endpoint that shows kind of what happens when things aren't perfectly okay. And we're going to go through those examples here momentarily. Now I've got this service running, or I will have this service running on port 9090, so it will be listening for requests coming in. And I'm actually just going to scoot that off to the side here. And then what I want to do is change where we're accessing here for our cart points sync URL. Say that 3 times fast. So I'm going to point to localhost, our service, our fail service 9090, and we're going to just go to the OK endpoint. And what I'd like to do first is just test to make sure everything is fine. Everything is indeed okay. So I will run those. We have both of them running, and I'm going to go ahead and push an order, or actually a representation of the points that we're getting. So we have a payload that came through, and we're getting back a complete signal. So everything is fine. Everything is okay. So let's see if we can fix that at this point. So what could happen is that we might have the case where we would time out coming back. So what I want to do, and I'm just going to expand this again so we can see this a little bit better. So if we have the case where we have a timeout, what we want to do is set a timeout here. Let's say that we're going to allow 10 seconds for a timeout before we just give up on the entire interaction and just pack it in for the day, right? And I'm going to change this to our timeout endpoint in our fail service, and we'll see what happens at this point. Now, I do want to actually show one thing because things can get a little bit messy here. So I'm going to go ahead and show this, perhaps the messy version first. So I'm going to go ahead and restart this. Well, actually the messy version second, the absolutely clean, everything is happy version first. So we have a 10-second timeout. If we go over and look at our timeout endpoint, which we will get as soon as I send this, we can see that we have an 8-second delay. So we've got our timeout payload. We've received this payload, and we're going to wait 8 seconds before we send something back, but we have a 10-second timeout, so all is well, right? And indeed, all is well. We get back a completion indicator. So that's great. But what happens if we have, let's say, a 5-second timeout? So let's go ahead and restart this now. And of course, this is where things can potentially get messy, and this gives perhaps more information than we necessarily need. We may want to handle things a little more elegantly, but this gives you kind of that raw, exposed look inside at what's going on. Now we've received our payload here on their fail service. Coming back, we get this rather large trace. And if we go up here, we can see that we've canceled here. So we've got our indication that we just gave up, right? We waited 5 seconds, didn't get what we needed, and we just gave up. We canceled the request. And that's okay, but we can actually go ahead and tidy this up just a bit. If we insert an on-error resume here, what I like to do is take that error, and then we'll just do some things with it. Let's take a look at it. So error, and we'll just take that. Actually, once again, I'm going to expand that, and we'll do this and get our localized message, and then we'll just return a mono empty. So that, that should make things just a bit neater for us in terms of our logging. And we'll go ahead and restart that, and we'll send our latest update here. Oh, well, of course, we should probably wait for that to happen. Wait for everything to come up. And then there it is. We're waiting 5 seconds. It comes back. This is a little bit cleaner. So it just tells us, hey, we didn't observe any item or terminal signal within that 5 seconds that we expected, that we specified. So yeah, we're just going to go ahead and continue and do kind of a graceful degradation, if you will. So now that's what happens if we need to do a timeout. Now, what happens if, and there are some cases that's very valid, right? If in cases where we know that if something isn't there when we expect it to be there, it's likely not to be there even if we wait a bit longer. But there are going to be times where it makes a lot of sense to have something like a retry. So we're going to maybe examine what happens when we retry. So we'll retry when, and of course we need to indicate what happens if we don't just want to send a bunch of requests back to back to back, because if something is not available at this point in time, if we wait 3 milliseconds, it's probably not going to be available then. So we need to give it a little bit of time for things to heal or to come back or to become available. So we're going to back off. I'm going to indicate a back off. In this case, I want to give 5 attempts, right? And I'm just going to back off a little bit each time, a little bit more each time. So we're going to increase our back off here by 1 second per shot. And there we go. And then I do also need to change this to, instead of going to the timeout endpoint, because I want to demonstrate retries at this point, we'll go to the retry endpoint for our fail service. And we'll restart that. And then once it comes back up, and I will give it plenty of time to come back up this time, then we'll see what happens when we make a request. And I should actually show really quickly what happens. For our retry endpoint, we will accept requests. And then, of course, the first few times, in this case, if the counter is under 5 times, so the first 4 times, we're just going to send back a bad request response. And then after that, any subsequent requests we get will return a success. So there we go. So let's go ahead and pull this up and submit this. So we see that we've got a request. We failed once, we failed twice, we failed 3 times, and we can see each time that we're getting a little bit more of a delay to give things time to recover and to do things elegantly, gracefully. And of course, after that 4th time, we make that 5th request, and then it's a successful retry. So that works out very nicely. And we can see here that we have errors until we get a completion signal. So that's great. That works really, really well. Now, just to switch gears here for a moment, what I want to do is show another way of operating, because there are times that you want to limit what comes out of requesting applications and not just accommodate on the back end what to do when things go wrong, or on the front end in terms of, okay, retry this many times or just give up after a certain amount of time. There are going to be times where you'll want to limit the amount of requests, the number of requests that are being issued from a consumer, from an upstream service. So what I want to do at this point is just to configure a rate limiter. So we'll do that, rate limiter, and we'll call this cleverly enough rate limiter. And I'm just going to define a rate limiter of a few different parameters. I'm going to set this up. We'll just call this our Dataflow rate limiter. And then I'm going to use rate limiter config to establish a custom rate limiter config. And we will limit, if I can type, and we're going to limit the number of requests going out to 5 per period. And to define our period, we'll define our limit refresh period. And this is the amount of time that we would specify to fence off those number of requests. So in this case, for each second, we want no more than 5 requests to be allowed. And then we want to define what happens in terms of a timeout duration. And clearly I have gotten out of my, there we go. So our timeout duration. And we don't want to have things kind of hung up forever. So I'm just going to establish this for, let's say, 25 milliseconds. And then let's build this and clean that up. So now we have a rate limiter that we can press into service. In order to use that rate limiter, we actually need to send multiple requests. So I'm going to I'll just edit this. That's fine. So I'm going to save all, and I'm just, instead of a single order, what I'm going to do is establish a flux, a range, and we'll just say 0 to 10, right? And I'll map each of those. And we'll take the value that comes out of each of those, and we'll just map that to an order. Perfect. And that is pretty close. What I do want to do, though, is to set up an on-error resume so that I can take that, and when that error comes back, so when we exceed our rate limit, we want to do something with that. So I'm just going to, once again, set this up, and we'll just print this out so we can see kind of what's going on. We'll log this, so get localized message, and then we'll return, once again, oh, come on, IntelliJ, return mono.empty, That's kind of a nice way to wrap things up. Yeah, so that looks pretty clean. And at this point, what I want to do is just go down here and we'll just clean this up, and let's do a transform deferred, and we'll take our rate limiter operator, right? And we'll set this up to use our rate limiter that we've defined. Now, the other thing that I need to do, or can do, I'm just going to go ahead and go to the OK endpoint because, you know, that's we don't want to mix things up a bit. I think it's clear to see what happens when you don't mix concepts, so you can see very clearly what's happening when it's happening. And I'm going to go ahead and similarly go ahead and clear that up so that now, oh, what did I miss here? Oh, yes. Well, that's helpful. So go ahead and restart that. And once everything is running, we'll go ahead and push that update. Yeah, so we see that we got through exactly as we expected. We limited the calls to 5. 5 got through, and then we see that our rate limiter doesn't permit further calls. And that's exactly, again, what you want to see when you limit the requests going out from a particular upstream service. So with that, that's pretty much all for me at this point. I will go ahead and hand this off to Mario. Thanks so much, and here we go.
Well, the way that pod death works in Kubernetes is that once a pod is scheduled on a node, it lives and dies with that node. And so if that node dies, the pod dies with it. And what happens is we have higher level concepts than pod, these things called replica sets that create a new version of that pod. So the answer is yes, if your pod dies in real life, you die, but you immediately get cloned with all of your memories, so you don't even notice, right? I think so. That's what's really happens when your pod dies.
The code is a far sight more robust, but we still don't have real coffee in the database. The coffee catalog should, of course, originate its coffee from some external configuration. In this segment, Mario Gray will look at ways to do just that with Kubernetes config maps and Spring Cloud Kubernetes.
Hi, Mario here. I'm a developer advocate for Spring at Tanzu. Nothing seems boring to me like a coffee shop without coffee. What kind of fly-by-night shop has no coffee? I need caffeine here. In this section, I will show you how to source coffee beans, not from an organic farm, but from configuration. I will demonstrate how to use Spring Cloud Kubernetes config to read, load, and reload application properties from config maps. Then we can create coffee beans, and then we can code some more. Let's go. Application properties. So we have application properties that we can actually incorporate into our application runtime state. In that case, we have coffee, Sumatra, we have breakfast blend, we have blend of the day. We're going to read this as an environment variable, and then we're going to push that into our database. So let's go ahead and add it. Okay, we're going to add a new class. This class is Cafe Initializer, and it is a component. And it is also going to use required args constructor and a log4j logger. We're going to need an environment. Then we're going to need a repository. We have a coffee repository. Then we're going to write an event listener that will listen to application ready events. And it will execute method runme. And runme does something like, what should it do? Coffees equals, let's say it pushes env.getProperty. That property is called cart.coffees. And we will take that and say val coffee stream, and we could create a flux of coffees, of the coffee names. We'll split, and then we'll filter it. We'll say object utils is empty. If it's not empty, we want to keep it. And then we can turn that into an actual coffee bean. Okay, so we have that. Now we want to do something to our database. Let's initialize our database by first deleting it, and then adding the coffees. Let's then add all of the coffees. So we can say then many and save all. What we're going to do is save that coffee stream. Then we can monitor what the output of that is using subscribe. Okay. So that's gonna get us a nice application that knows what coffees are in application.properties, so that we can serve coffee from our command line or curl or a web service endpoint. So we have the first few adding coffee, which is Sumatra, breakfast blend, then blend of the day. What I would like to do is, I would like to say .trim. There we are, so I like to do that. Okay, so let's check that out from the curl localhost 8080 cart coffees. We have application.properties now, but we wanted to load it from the cloud. And the best way to do that is to add a resource to our dependency tree. So our application properties runs fine, but if we want to pull new properties, then we always have to restart the application. That's probably not the best thing to do. So let's go ahead and change that a little bit so that we're not only changing the application state, but also our application is able to be made aware of property changes. So let's go ahead and say pom XML, and we'll do dependency addition, and we're going to add org Spring Framework Cloud. So we're going to add not that. Of course, it thinks I want that, but okay. We'll add the Kubernetes Fabric 8 configuration dependency, and that's going to make Spring able to select a config map and pull its contents into our property maps. Now I can read that as a environment from our property map. Okay, so after adding it, I am going to need to use something like a Bootstrap property. Let's talk to Bootstrap properties and say Spring application name. We'll call it cart. Then we could say Spring Cloud Kubernetes config namespace as BK. I want to configure reload. Then I want to configure the mode. So that's the event. And this is the configuration source. So whatever it finds in this config map will be used as a configuration property. All right, so the next thing we want to do is, we know that we have this. We have a POM file here. That POM file has what? Our Kubernetes Fabric 8 configuration. So if we load this right now, if we hit play, we should see the config map. So we have the Shakes, Cloudy Blend, Sumatra, Breakfast Blend, and Blend of the Day. If I went into the terminal and said curl localhost I'll have the shakes, cloudy blend, Sumatra, and so on and so forth. Let's add one more. We have a more genuine coffee here. This is going to be called the procrastinator. Let me apply it. And then let's check the endpoint, the procrastinator. Okay, great. So we know now that application state is maintained as a steady state, but it is also able to contain new properties as they're fed into config maps. So now that we have config maps completely taken care of, what's next?
So no, Kubernetes is generally not the right abstraction for developers, but Kubernetes was built to be built upon. It's more easier to build that right abstraction for a developer based on the primitives that are driven by Kubernetes. And a key insight here is that there is no one system that's going to solve everything for all developers. Our world is specialized to the point where, there is no one size fits all solution. So the goal with Kubernetes was to provide enough so that you could provide the rest of that experience in a way that really fits the needs of the developers that you're targeting. And if that higher level abstraction doesn't work in some situations, you have a much more, even slope off the sort of the beaten path versus having a cliff into the ocean, which we see with a lot of other systems that are really aimed at developers. So the idea is that Kubernetes provides a great baseline, but it's not going to get you there all by itself.
We've got a cart service and a point service. There are some calculations to be performed once an order is placed before updating the point service. In this segment, David Turanski will look at stream processing with Spring Cloud Dataflow on Kubernetes.
Hello, my name is David Turanski. I'm a Spring developer currently working on Spring Cloud Dataflow and its related products. I also spend time with our customers as a Spring advisory architect to help them get the most out of Spring. I'm happy to be here today to talk about Spring Cloud Dataflow and to show a brief demo. And boy, do I love coffee. So let's get started. Cloud Dataflow is a runtime environment that provides tools and services that provide a rich development experience when you're composing complex topologies for streaming and batch data pipelines. These are topologies of distributed Spring Boot applications that use Spring Cloud Stream or Spring Cloud Task and Spring Batch, or a mixture of both. And Dataflow allows you to create these topologies with a graphical editor or various other ways of doing it, and manages the deployment and undeployment of these distributed applications as a unit, which is very convenient if you're doing a lot of this kind of thing. So the best way to get started with Spring Cloud Dataflow is to go here to dataflowspring.io, and you can find out anything that's related to Dataflow here. It's a great way to get started. For example, we can look at how to install on a Kubernetes cluster using a Helm chart, which is what we've done here. On our cluster, we've already installed Dataflow using the Helm chart that is published on Bitnami, and so you could follow these instructions for the open source version and do what we've done. So here we see Dataflow running here on our cluster. It consists of a few components: the Dataflow server itself, which is the main point of contact for Dataflow users. We also have a skipper server, which Dataflow uses to delegate certain tasks related to stream deployment. but is not generally used by end users directly. We've also deployed the RabbitMQ message broker, which will be used by our boot applications to communicate when they're running in the stream. And we also have a SQL database, MariaDB in this case, which Dataflow components use to keep track of the state of deployments, stream definitions, task definitions, and batch and task executions and things like that. So we also have here deployed the cart service and the point service. And so to complete the application, we need a bit that's going to calculate the points. So if we post an order to the cart service, we want to get those that order details and compute the rewards points, and then post that to the point service. So to do that, we're going to build a stream in Spring Cloud Dataflow. So let's take a look at the Dataflow dashboard. So the applications view is what you land on. And we can see we've already pre-registered all of the out-of-the-box applications that are provided by the Dataflow team that can be used to perform many tasks when you're building stream pipelines. So we have a number of sync sources and processors, which are components used to compose streaming data pipelines. And there's a lot of integration with common open source products. We see Redis. We can use RSocket, S3 for sources and syncs. We can read from S3 or write to S3. We can use SFTP, Rabbit. We have a HTTP request processor, which is a processor that takes its input and calls out to an external web service and returns the result, forwards it on to the next component. So lots of things like that. And we also have registered our custom applications, in this case, our points calculator sync. So we'll take a look at that points calculator sync in a second. We can create the stream by composing these things using a graphical editor to drag and drop. So we're going to use the HTTP source here to expose an HTTP endpoint to the cart service. And we're going to use a points calculator sync. And so before we complete this, let's take a look at the source code of our sync application. And we started by going to start.spring.io and creating a points calculator sync artifact using Java and Spring Boot and Maven. And the dependency here are Spring Cloud messaging, the RabbitMQ binder, and the Spring Boot actuator. The Spring Boot actuator is important when you're deploying to Kubernetes because it supports the liveness and readiness probes that we're going to need to determine that our application are ready and have been deployed. So we go ahead and create that project, and then we can write our custom business logic. And here we have a Spring Boot application, and we see that we're importing an HTTP request function configuration. This is something that comes from the out-of-the-box stream applications that we looked at. And I mentioned the HTTP request processor. That is a processor that's backed by a function, and we can also reuse these components at the function level. So every one of these stream applications that we saw listed on Dataflow have also a function that it does the implementation itself, and these functions can be used and can be composed when you're building custom applications. So we can use the function directly, as we've done here. We have registered two functions, actually. One is a function that takes a purchase item and returns a points object. And then we have a consumer of the points. And we're going to compose these functions so that the output of the calculate points will be used as the endpoint for post points. And we're going to compose them declaratively. We'll see how to do that in a second, but let's just look at the code here. So we get some JSON in that we're representing as a purchase type. It's got a username and an amount. And so we're basically just going to create a points object that uses that username and take the amount and multiply it by 100 in this case to calculate the points. So no big deal there. When we post the points, we're going to use the HTTP request function as a dependency, and that comes from the configuration. So we know we have that in our application context. And the HTTP request function is reactive, and it requires a flux of messages. And in this case, the message payload is going to be of type points. So you have a Lambda here that's just going to apply the function directly, and we're going to block on that. Sorry, Josh, we should have been end-to-end reactive here. I know you wrote the book on that, but just for simplicity, we'll do it synchronously in this case. So to compose a function declaratively, we use a Spring Cloud function definition that has a sort of a mini DSL. It says take the calculate points and then take the output of that and use it as the input to post points. That composition of a function plus a consumer acts as a consumer, and Spring Cloud Stream is going to use that function definition to bind to a consumer to treat it as a sink. And so we've already built the Spring Boot application as a Docker image using the Spring Boot Maven plugin, the build image task in the Maven plugin. And so we've got a Docker image and we've registered that in Dataflow as a custom application here. The HTTP request function requires an endpoint, which is given by this property, HTTP request URL expression. And we could have put this in our application definition as well, but since we've already deployed the Docker image and we don't want to rebuild it, we can just set it here in the stream definition using the stream DSL, which we see here. And so the first part of the URL is the point service IP address, and the endpoint is points, and then it takes a username, which is going to be dynamic in this case. So we get that from the message payload that it accepts. And we're going to take the username field from the message payload. So it's pretty much all there is to it. We create the stream, and it's asking for a stream name, so we'll call it points, and create the stream. And we see that the Dataflow server has accepted our request and is now deploying the stream. Sorry, it's created the stream. Now we need to deploy it. And we're going to deploy this orchestration as a unit. We have our source and our sink as two separate applications. And we have the opportunity to add more properties. We can configure the memory, CPU, disk for each of the pods. We can set some other properties, application level properties like we have here, and then just go ahead and deploy the stream. But in this case, we're just going to take what we have and deploy it. And the Dataflow server has accepted our deployment request. And we can see that we're creating a couple of pods for the HTTP source and the points calculator sync. Dataflow prepends the name of the stream to these so that we see they belong to the same stream, and also a unique ID, deployment ID. So let's go ahead and wait for that to finish deploying, and then we can run the rest of the demo. Now the stream has been successfully deployed, and we can go ahead and try our demo and see if everything's working end to end. So here we see that we have the HTTP and the points calculator pods running and ready to go. These Dataflow appends the name of the stream, which is points in this case, and kind of a unique deployment identifier for it. And so now we want to post an order to the cart service, and I really love Sumatra, so I'm going to buy 4 of them. And we do that. We got an OK, which is good, and we should have 400 points now. So let me buy some more. Five more. And now we have 900 points. So everything seems to be working. Thanks. That concludes the demo.
One of the things we worked hard to do with Kubernetes is really work to make sure that we were careful about breaking things down. I think we like to talk about it as Unix philosophy. This idea that you have a bunch of small composable pieces that you can put together to do larger things. And so you can take a pod and you can use it to run a server, where the goal of these higher level things, this would be a replica set and a deployment, is to, keep this thing up and running no matter what. Meanwhile, there's folks that are taking that same abstraction of pod and building, systems for running stateful, workloads, things like databases. And so we have abstractions like stateful sets. You can also do, say, a database migration while you're doing a deployment by running a pod to do that migration, but having it only run until it says that it succeeded. Similarly, if you're doing data-centric data flow types of things, you may want to have a pool of workers, and you can have some other controller and, talk to the Kubernetes API to dynamically size the number of workers you have based on the amount of data that you're trying to process. Similarly, there's folks through projects like Kubeflow looking to adapt Kubernetes so that it works well for machine learning applications, reusing some of these same primitives, but really with a different context and different type of application in mind. So one of the things that I like to say is that Kubernetes is a platform for building platforms. And that really comes down into a couple of things. Number one is these core sort of like Lego block primitives that you can put together to do all sorts of different things. You can use the same pod for doing serving, for doing data analysis, for doing one-shot jobs. That same abstraction can be used in different ways. But that's just not enough. I think one interesting thing happened as we built Kubernetes. All of a sudden, as it saw success, people wanted to bring all these new features, and we didn't want the project itself to actually be a gatekeeper for what features could be part of Kubernetes and what features couldn't. So we started adding, and this was Brennan Burns, who's a good friend, one of the other co-founders of Kubernetes, created this thing called a third-party resource that eventually became a custom resource definition. And this is a way that you can extend Kubernetes so that you're sort of adding new primitives that act just like the built-in primitives. And so more than any other cloud system out there, Kubernetes is built to be extended. You can actually be part of building your own flavor of Kubernetes, or using any of the specialized systems that are targeted at the types of problems that you're trying to solve. So a key aspect of Kubernetes is this idea of declarative programming. You tell the system what you want, and it automatically makes it happen. And that's a much sort of more, friendly, easy, sleep better at night way to deal with these types of systems. I think a great example here is that, as we look to, hopefully someday the self-driving car world actually working, when you get into your self-driving car, you're not going to tell it, oh, take a left at the next corner or turn right here. You're going to tell it, take me to the grocery store or take me home. And that's what we want out of infrastructure. You tell it what you want and it figures out the optimal way to be able to get there. And so the key way that Kubernetes does this is through this idea of reconciliation. You have desired state, and every time you look at a Kubernetes YAML or object, you'll see that there's spec and status. Spec is what you want, status is the current state of what the world is. And so what happens is that spec and status is paired with a program that's running a reconciliation loop, and it wakes up, takes a look at the spec, takes a look at the real world, and tries to make some forward progress. It reminds me of when I went hiking in the Grand Canyon with my kids a couple of years ago. We got to the bottom, and by the way, when you go to the Grand Canyon, they say down is optional, up is mandatory. So we got to the bottom when we were climbing our way back out. Our desired state was to be back at the top at the south rim eating ice cream. But we weren't going to get there in one step. And so the idea there is relentless forward progress. Every time you take a step, you just want to get closer to your goal. And that's what Kubernetes via desired state and replication helps you do when it comes to your infrastructure.
So far, we've looked at a business application running on Kubernetes. One of the most promising aspects of Kubernetes, however, is that it's imminently programmable. You can even extend it using Spring, as Tiffany Jernigan will show in this next segment.
Hi everyone, I'm Tiffany Jernigan. I am a developer advocate here at VMware. So let's talk a bit more about Kubernetes. So Kubernetes has a vast API with a lot of extension points. One of the API components is a controller. So what are controllers? The Kubernetes docs provide the best description of what a Kubernetes controller is, so I'm not going to try making one entirely up on my own. So in robotics and automation, a control loop is a non-terminating loop that regulates the state of a system. So say you want to make a pour over coffee and you need some boiling water. So one example of a control loop is the thermostat in the electric kettle if you're using one of those. So when you set that temperature, it's telling the thermostat about your desired state. The actual water temperature is the current state. The thermostat acts to bring the current state closer to the desired state. Then you can use it to make your pour over. So in Kubernetes, controllers are control loops that watch the state of your cluster. Then they make or request changes where needed. So each controller tries to move the current cluster state closer to the desired state. So now let's go and start with the demo. Now we're going to start at Josh Long's second favorite place on the internet, start.spring.io. So this is the Spring initializer. So instead of having to write a bunch of this stuff ourselves, it will give us some of the code and the POM XML, etc. on its own. So I'm going to give it a group name and I'm going to call it Booternetes. And the artifact, or what the name will also be, I am going to call that Kubernetes controller. So basically that's all we need right now. So then I can just go and I can generate it. So I'm just going to save it here as a zip file. So now if we look, I can see that. So I can just do unzip, do that the file. So now if we go into the Kubernetes controller, we can use IntelliJ to open it up and create a project. So if I do idea and then do it on the POM XML. Cool. So now we can dive into it. So the first thing that we are going to do is we're going to modify the pom.xml that was created. We need to add a dependency in there for the client Java Spring integration for Kubernetes. So I'm going to copy and paste that in here. So we're going to be using version 12.0.0. Of course, you could use parameters and then add that in here, but I'm just going to put it like this by default. So then next, if we do a right click, we'll need to reload the project. So now let's look into the code. Okay, so here's the code that we got from the start.spring.io. So as you can see, it's just the basic outline of what we kind of need. So the first thing that I'm going to create is a shared informer. So to start off, what are informers? So informers basically see what objects are there and watch their desired state and the actual state. If you don't have one, you could constantly query the API, but that would result in a lot of redundant calls. So the shared informer basically is a cached version of the informer to be faster and easier to share amongst informers. It's also more memory efficient. So we'll want to have a shared next informer for both the node and for the pod, at least in this case, it depends on what you're trying to keep track of. So basically what the lister is going to be doing is it's going to get the current nodes and pods that it can find using the informer that we were just creating. All right, so now I'm going to create the reconciler. I'm going to call it reconciler, and then we will give it the lister and v1 node. So then we can call that node lister. And then I'm also going to give it the pod lister as well. Cool. Okay, so then we're going to use the Lambda, and I'm going to return the request. I am going to create this using the names. I'm going to use the namespace BK for everything that's going to be running. So I have our namespace is BK. And then, so now I want to know what node is it. So for our node, and then this is where we use the node lister, and I can get what it actually is with the request and getting the name. Okay, so now I'll just print that out. So node, and then we're going to get the metadata and the name. Okay, so now the next thing we need to deal with is the pod lister. So basically I want, for this node or whichever the nodes are, I want to know what pods are there. So this code isn't going to be like, oh, do you have a pod that went down or something that came up? It's just going to be very, very basic, and it's going to just list the nodes and the pods as the controller calls the reconciler. So if we have our pod lister, and then so we need to have the namespace that we just had earlier. We have list, stream, and then we are going to go and get the name of the pod. And then so for each one of those, we're just going to print out what the pod's name is. And then lastly, we are just going to return a new result. Okay, cool. So now we have that reconciler. Again, it's basically all this one is doing. You can have it do a lot more stuff, but this one will just basically tell you what the nodes and the pods are every time. Now we need to have the controller. So basically the controller is a combination of everything that we just created above. It's where everything comes together. Basically, you may have heard the phrase where the rubber meets the road. So now let's go and create that. So I'll have another bean, and this will be a controller. So it's going to take in the shared index informers that we created above, the shared informer factory, and a reconciler. So with this, we're going to return a controller builder. It's going to take in a default builder. So that is our shared informer factory. We're going to do a watch on the node that we have. Next, we're going to see whether the pod informer and the node informer have synced. We're going to take in the reconciler. Give it a name. So we could call it Booternetes controller. And then build. Cool. So now we have like the main meat chunks of the application. So the last thing that we need here is the command line runner. Basically, it just kicks everything off when the application starts off. So I am just going to copy and paste that one as well. So here you can just see that it just starts all the registers and informers and it runs the controller. So now that we have that, let's try running it. So if we open up the terminal here, so right now I'm running Kubernetes locally for just being able to go and test this. So what we can do is we can just do a maven clean package spring boot and run. And this will take a few minutes. So right now we can see that it's calling the node Docker desktop. Okay, so now if we open up the terminal, we can just make sure that we're in the right namespace. So I want it to be in the namespace BK. So if we do, I have a tool called Kubernetes, and so then I can see what I'm in. So right now I'm in BK, cool. So I have K aliased to Kubernetes. So if I do a kget pod, we can see that there's something there. So that's why it's just listing the node. So if I want to create a pod, so I could just do K run. So if I want to have BusyBox, for instance. So now we can see that that's created. And if we wait a little bit, we should be able to see that it will end up showing up here with our controller. And with that, we have working controller. There are some obvious next steps. We could containerize this controller with Spring Boot's built-in support for build packs. We could even turn this application into a Spring native application, which uses build packs to produce super lightweight, ultra-fast, architecture-specific binaries. Thanks for sticking around with me for this demo, and hope you have a good rest of your day.
systems like Kubernetes is that traditionally when you run a server, the set of APIs that you have to deal with are the ones provided by your underlying operating system, things around, file systems and networking and all that. With systems like Kubernetes, and I think there's other classes that fall, of systems that fall into this, you have a whole nother set of APIs that you can actually start to interact with. So you have a richer set of, building blocks for building your distributed systems, for building your applications. And this can be as simple as something like a health check in Kubernetes. You can tell Kubernetes that, hey, every 5 minutes, I want you to go ahead and actually run this command in my context or hit me at this particular path, HTTP path. And if you don't get a success, then you know something's wrong and you should start the whole self-healing process. So that's a new interface between the application and the underlying system that fundamentally leads to more reliability. And that's a simple place to start, but you can go all the way to creating your own controllers where you can orchestrate and actually turn your application from being a single process to really something that works with the system to make sure that you're running the right things at the right time to solve the problem that you're working with. And this comes in things like Dataflow, where you need to make sure that you have a scalable, dynamic set of workers to deal with the incoming stream of data. That dynamism is what Kubernetes was built to do. And so you can embrace that by accessing this whole other set of APIs from your workloads, from your programs.
We've got a working system, but its HTTP APIs aren't secured, compressed, or even accessible to Core's clients. To address these kinds of concerns, Chris Sterling will look at the Spring Cloud Gateway for Kubernetes.
My name is Chris Sterling. I'm the Senior Product Line Manager for our API management within VMware Tanzu. And my focus really is around how do we operationalize the Spring Cloud Gateway, API portal, and the whole API management experience. And so what we're going to show you today is how we've done that on Kubernetes, creating a Spring Cloud Gateway operator, an opinionated version of the gateway itself that even has some additional filters and predicates. And then also on top of that, show you our API portal, how it's able to display the auto-generated APIs that we provide. All right, today I'm going to show you how I'm going to install Spring Cloud Gateway for Kubernetes, which is our commercial version of Spring Cloud Gateway. And in here, we're actually using an early beta version that's coming out very soon. If I run the install script, this should install the Spring Cloud Gateway operator, which is a Kubernetes native operator deployed into the Spring Cloud Gateway namespace. So we'll go ahead and go to that namespace right now and show you what the operator looks like when it's on the cluster. So the operator here actually deploys a pod and it has a service on it. Now the service is going to be interesting because we're actually going to expose an open API endpoint for all of the API routes that are going to be dynamically updated on the actual gateway instances that we're going to create later. But for now, just know that the operator itself is running and waiting for custom resources to be applied to the cluster in YAML files. So we're going to go ahead and look at those now. Let's go to the gateway. In the gateway, we actually have a gateway YAML file, and we also have an Ingress file. And in order for Ingress to work, we actually need to have Contour installed. So I'm going to go ahead and install Contour onto the cluster. Project Contour is an Ingress controller that you can use with Kubernetes. It's open source, and also happens that much of the work is done here at VMware. All right, so now we have the Ingress controller installed. And what we want to be able to do is go to our BK namespace. We'll do a get all. You'll notice there's a bunch of resources already deployed. There's services like cart service and point service, which we're going to utilize very quickly here and expose those through a gateway. So our gateway, just to show you for a moment here, our gateway is defined fairly simply. We actually have a Spring Cloud Gateway kind custom resource, and we've given it a name of Booternetes-GW. That's what it's going to create on the cluster. Now we're using nip.io, which is a dynamic DNS service that we're going to be using so that we can get it from the outside world. Just notice I had an actual problem with my URL. I need to make it HTTP. And through this gateway, we are now going to be able to do a apply of the gateway to the cluster in the BK namespace. So if I were to do a get all, pipe it to grep for Booternetes, what we should see now is we actually see a pod, a service, two services actually, and a stateful set. The stateful set is the deployment. It's managing the gateway instance pods. So now we have one pod because we're using the default of a single node. You can actually set this count to, and why don't we go ahead and do that right now? We'll just play around with it now. Count 2. All right. Oops. All right, so now we've added the count. We're going to go ahead and apply it again. Check it out. And you'll notice that we have a 0 of 2 now as well. And you'll start to see multiple instances come up. We actually have one running at this point in time. There should be another one coming up as well. All right, and the service is running on cluster IP at this point in time. Let's go ahead and create an ingress. So just to show you our ingress file, so you know how Contour works. We've named it with Booternetes ingress. We're saying in the BK namespace we want to deploy this ingress, and we want to give it the URL from the nip.io. That's going to allow it to redirect any traffic coming in on the IP address with that particular name to be redirected to this gateway instance. And in this case, the service name is Booternetes Gateway, or GDub, and it runs on port 80. So what we're going to do right now is apply the ingress. Okay. If I do a get ingress, you'll notice it has our IP address, and it also has our new host name that we're using. Let's see how our Booternetes is doing. So we actually have an instance running, so our pod is there. And let's go ahead and see if we're able to see our gateway, if it's running. So we're going to use the management port. You'll notice that the main APIs are available on port 80, but on port 8090, which is not exposed through any ingress, you can do a port forward on the pod and then go to a browser. And when I go to the browser, I can see the health of that particular pod is actually status up. So we're healthy. Let's go ahead. Actually, I'll show you something else. So currently, the gateway routes metrics endpoint or actuator endpoint is not showing any routes defined on the gateway at all. So we're going to dynamically update that for the cart service. So let's go ahead and go back. Let's go into the cart service. Actually, I can just show you right here. The cart service actually needs a route config. So the kind of that custom resource is Spring Cloud Gateway route config. And we're going to call it the cart service route config. It's going to be pointed at the cart service, which is the name of the service on the name of the service on the cluster in the BK namespace. So there it is. And on there, we're going to have a couple of different API paths. One of them is API cart coffees. And then we also have API cart orders. Now, by default, we automatically strip off the /API when we route the traffic through the gateway to the cart service itself. So the cart service is only going to see /cart/coffees and /cart/orders. So that's all done by default. The orders is a post endpoint so that we can add some orders later. And you also notice that you're able to add a data model to this and define it. In this case, when you create an order, you say which coffee, username, and quantity that you want. And all of that is provided in the route configuration file. Okay, and we're also going to deploy the point service, and point service on its own is going to have its another route config, and in there we have /API points with a username. So in this case, I'm going to see how many coffee points Josh has in his account. And you'll notice that both of these are in their own repos. So the point service is actually in the point service repo, and the cart service route configs in the cart service repo. So each one of these can have their own life cycle and be able to evolve their APIs separately. All right, let's go back over and let's apply some route configs. So in this case, we're going to do the cart service route config. The other thing that we need to do, though, is we actually want to map it into a gateway instance. So I'll show you what a mapping file looks like. So I'll just give you an example. Really what it is saying is, okay, now you have a route configuration file that's defined for a service. You have a gateway that's been defined as well. Well, now put these API routes onto this gateway is all that we're saying here. So the gateway ref is here, and we have the route config ref here. And we're just saying now map them on, and that's going to actually define the routes onto the gateway. All right, now we're going to apply that mapping file to the BK namespace. And so that's going to map the cart service route config over onto the Booternetes GDub gateway instance. Now that we have the route config and the mapping applied to the BK namespace for cart service, we should be able to see some routes now defined. Yes, they are on the gateway. Okay, and let's go ahead and do the same thing for point service. So we'll go ahead and do the route config, and then we'll do the mapping as well. Now that should allow you to see that the route config and the routes actuator endpoint should show you now the API points endpoint as well. So now that one is available on the gateway as well. All right. So now I'm going to do a few curl commands to test this all out because we have everything installed. Let's see here. So our first command is going to be, let's see what the list of coffees are. Ooh, wow, we got a lot of them. The Proficientnator, Al Cappuccino, a lot of great different things that we can order here. So that's great. And Sumatra is one of them. I really like Sumatra. So what we're going to do next is we're going to go ahead and send in an order back. Well, I think Josh needs some coffee. And let's kind of check out how many points Josh has. Oh, Josh has 400 points already. He's a heavy coffee drinker. I think he needs some more coffee. So let's go ahead and order a Sumatra because Sumatra is the best coffee of all. And now that we have some coffee we just ordered, let's see if we got any more points for Josh. Ooh, 800 points now all of a sudden. So Josh is a veteran of the coffee Sumatra thingy that we're doing here. All right, so Josh, great job. Drink your coffee. And now that we have all of this information, we've now used the APIs. We're going through the API or through the Spring Cloud Gateway for Kubernetes instance. Everything is working nicely. What would be really cool is if I was an API consumer, maybe I want to see what the APIs look like in a cool portal. So I'm going to go ahead and install that right now. So we actually have an API portal namespace. Let's go ahead and go there. You'll notice that there is nothing in there at this point in time. So let's go ahead and install the API portal, which just got released a couple weeks ago. And pretty much the same thing that we did over on the Spring Cloud Gateway when we installed the operator. Now we're going to install the API portal server. It's going to create a pod and a service that we can put an ingress around. So that'll be our next step to expose that service outward using nip.io. And voila, API portal has been installed. Let's do a kubectl get all. Oh, there is our API portal server, and it's currently running. So let's go ahead and apply the Ingress just to show you that what our Ingress looks like. Let's go ahead and go into the gateway directory, and we're going to cat the API portal contour YAML. Pretty simple. We're going to put the API portal with the nip.io address. We're going to apply that now into the API portal namespace. We do Ingress. Voila, another Ingress is created. So now we can go over, well, actually, I better copy that really quickly. Go to our portal and see if it has all the information we need. Oh, it's using the defaults. You know what? We need to point it at our Spring Cloud Gateway instance now. So we're going to do a fairly simple command where we're going to set an environment variable on the API portal. So let's go ahead and do that. There we go. And what we're doing here is we're doing set the environment on the deployment, the API server deployment. And then we're going to set the API portal source URLs to my OpenAPI endpoint that's on the Spring Cloud Gateway operator. So once we've done that, all of a sudden it should be restarting the application with the new the pod with the new information about what sources it should be pulling from. So let's go ahead and do that. Oh, actually, while we're doing that, let me show you how cool it is that we have this OpenAPI endpoint. All right. If you're actually going to a browser, you'll be able to see that OpenAPI endpoint right here. You notice that from the route configuration files that were dynamically added to the gateway, we then auto-magically generate this OpenAPI 3 version specified documentation for your APIs. And based upon the types of filters and predicates that you add to it, we'll even add in some additional information for you, such as, let's say I had a rate limit on one of the endpoints here, the coffees endpoint on the cart, and therefore it shows you that a response code could be 429 at times if you're to hit that rate limit, and then it'll tell you a header with X retry in with the milliseconds that you should wait before you should try again. Okay? So we auto-generate that OpenAPI documentation. Ooh, there's the Booternetes APIs all of a sudden showing up. All right, so now I can go see if I can list my coffees out. Let's go ahead and try it out. We executed. Oh, and there's all my coffees. The jitterbug is one of my favorites. So great. Maybe Josh wants to have one of those later. So with that, we showed you around Spring Cloud Gateway for Kubernetes. We've actually applied some route configurations for our cart service and point service. We've mapped those onto our gateway instance, and then we showed you how those can show up automatically as OpenAPI documentation in the API portal. Thank you very much.
A lot of times people will ask me, what is the future of Kubernetes? And the truth of it is that as a community and actually as a vendor, our goal is to make Kubernetes as boring as possible. Good infrastructure is boring. You don't want to think about it. You want to focus on your problem that's going to actually move your business, move what you're doing forward. And so you really want Kubernetes to fade to the background. So our goal with Kubernetes is to actually make it disappear and really let you focus on getting to your work so that you can do what you need to do. So I think Kubernetes is great, and it's been the keystone for this entire ecosystem that you'll see through things like the Cloud Native Computing Foundation. And if you go to the CNCF site, you'll see this landscape page, and it'll be this sea of logos of all these projects that are adjacent to Kubernetes. This stuff is awesome, and it's also horrifying. Right? In my mind, I like to call this beautiful chaos because this is the sign of innovation. There's a ton of folks doing a ton of really interesting things, but as a user, as a consumer of this, it's incredibly intimidating. And so you feel like I have to know everything before I do anything. Our goal with VMware is to help to really be a gentle introduction into this so that Tanzu provides a great way to get started with this, to build your skills. And as you start hitting problems that go beyond what's built into our offerings, we want you to have access and the right grounding so that you can take advantage of this incredibly thriving ecosystem of other vendors, of partners, of open source projects, and really get the most out of the cloud native computing landscape.
And now, to help us wrap things up, it's Nate Schutta, who looks ever upward to the opportunities implied by platforms like Kubernetes.
All right. It isn't easy to architect cloud-native applications. There's a lot of moving parts. Distributed applications require a fair amount of plumbing. We're going to need monitoring and circuit breakers, and contracts, gateways, streams. We're going to need to externalize our configuration. I'll probably want to use some function, service discovery, load balancing, documentation. The list goes on and on. We can't afford to reinvent the wheel on every single project. At the end of the day, our customers want features and functionality, and that's where we should be focusing our energy and efforts. Now, there's any number of approaches that we could take to make this happen. We could just spin up our own hardware. We used to do that for quite a while in this industry. We could use some automation to make it easier to spin up that hardware. We could use containers to further abstract away even more of that bits and pieces. We could use a platform that hides even the containers from us. And we could go all the way to serverless. And now I don't have to deal with any of that. I just write a little bit of code and away we go. Now, the further down this stack I go, the more flexibility I have and the fewer standards, and I can do whatever I want. But if I need a very specific version of something, well, then I need to get closer and closer to bare metal. And of course, the higher up this hierarchy I go, well, the less complexity there ultimately is, the more operational efficiency we get. Now, the trade-off here is I don't have as many options. I don't have every language under the sun, and I have restrictions on perhaps how long something can execute. But it's all about the trade-offs that we need to think about as engineers. In our ideal world, we want to push as many workloads as high up the stack as possible. We want to work with these higher level abstractions. That has been one of the biggest shifts that I've seen in my career, is we have these bigger blocks to work with today. We have higher level abstractions. And anyone who's been in software long enough has probably heard someone at least paraphrase this famous Alan Kay quote, "People who are really serious about software should make their own hardware." Now, we've come a long way since then. Now, obviously, there are exceptions that prove that rule. There are some instances where, yeah, you probably still should build your own hardware, but they're the exceptions. Now, we've covered a lot of ground today, everything from gateways to teaching your platform new tricks. We've baked in some resiliency. We've externalized some configuration. We've talked about one of my all-time favorite subjects, coffee. But it's important to take a step back and ask yourself, why does this matter for you? Why would you want yet another layer of abstraction? My good friend Sam Newman had this great tweet a couple years ago where he said, haven't we just made things worse? We have all these layers that we now need to maintain and patch. And that prompted a great response from Josh, who said, well, that's why we want these platforms, so that we can just focus on the app and let the platform deal with all these other things. One of the most dangerous phrases you hear in organizations is, that's how we've always done it. That just won't work today. Whether it's convenient or not, business cycles have sped up. We have to adapt. We need to adopt the always be changing mindset. We need to deliver code in days, weeks, not months, not years. I remember the first SpringOne I attended as an employee. A gentleman from Scotiabank got up and talked about their journey from the traditional quarterly release cycle to doing thousands of releases. Now, to be very clear, that does not happen overnight. This isn't something we just decide to do on a random Tuesday, and by Thursday, everything's good. It took a huge change in culture and a lot of engineering effort and discipline, but it can be done. Now, how do we make these changes? If you ask a software engineer how to improve something, you pretty much guarantee their answer is going to be make it look more like software engineering. And that's certainly what we've seen with DevOps. Let's make operations look more like software engineering. Now, that, of course, means we as developers become that first line of production support, and you get paged at 3 a.m, you ultimately are going to write more reliable software. And obviously, I'm oversimplifying quite a bit, but by making this a more repeatable, automatable process, we've been able to release more often, which has given us yet another nested feedback loop. Now, As the Agile process teaches us, I can demonstrate progress and I can make adjustments based on what my customers are actually seeing. And that's an excellent feedback loop, which ultimately leads to better software. But it's not the only feedback loop. Now, I as a developer can work with my operators to reduce friction in this deployment process. And my operators can work with us as developers to make sure that we're baking in fault tolerance and reliability. This also encourages us to work in smaller batch sizes, which gives us ultimately less risk and makes it much easier and simpler for us to run experiments, try things out, do A/B testing. Allows us to be much more responsive to our business partners and changes in the business environment. Now, this does lead to increased developer velocity, which is fantastic. It also leads to higher quality production environments, which ultimately leads to better software, which gives us more business value. And that's really what this is all about. We need to get code to production as quickly as possible with high quality and reliability. And one of the things that I would love to see for our industry is to move beyond measuring ops on uptime, devs on velocity, testers on number of tests completed. And let's focus on how quickly we can get features into production. It's ultimately about us delivering business value. It's we as a team own this. And it makes me think of one of my all-time favorite books, The Grapes of Wrath, which for me anyway was all about this sort of social change from the I to the we. And that's what we need to embrace in software. This is a collaborative game. We need to work together to lead to better software. Now, at the end of the day, infrastructure is different than it used to be. There's been this massive, massive shift in our industry from these homegrown servers, this bespoke artisanal approach to software, which is fine for coffee, not so great when it comes to having reliable, repeatable infrastructure. It was painful. Now, things have changed. This is a good win for us. Servers have become a commodity item. We've used off-the-shelf software and chips to replace customized things. Now, what this has led to is ultimately a democratization of infrastructure. What in the past would have taken many months and countless emails and meetings can now happen in a matter of seconds. That's a huge, huge win for us. Now, the other side of that coin is it's very, very easy for me to spin something up and forget about it and forget to turn it off, only to see my cloud bill get bigger and bigger every month. This quote always makes me laugh. We dropped our cloud cost by 61% by simply going in and turning off things we weren't using. What this means, though, for us as developers is we have more responsibility. Now, these issues were always there. We just didn't have to think about it in the past. We could trust our operators to handle it for us. Now, that has led to a paradox of choice for us, which if you're not familiar, please go hunt down this TED Talk or the book that it's based on. We have to understand that this democratization demands more of all of us. And so to paraphrase one of the founding fathers of the United States, a well-informed developer is a prerequisite to successful cloud deployments. Now, the other side of this that we have to think about is, what do we want our developers focused on? I was talking to a colleague of mine, and he made this quote about, with this approach, some companies discover that my developers now need to be certified in their application framework of choice, their cloud provider, as well as their container orchestrator. Is that really what we want them spending all their time and energy on? The moral of the story is we just need to be prepared and be aware of that. And ultimately remember that as developers, maybe we want to be careful of what we wish for. So yes, we have more control. We also have more accountability. So let us never forget Uncle Ben's wise words. With great power comes great responsibility. We can shape our platform. We can continue to move up the abstraction hierarchy, but never forget it's about us getting features and functionality into production in a reliable, repeatable manner. Thank you. Good luck. Back to you, Josh.
Thanks so much for watching. We hope you got something out of this and that you had fun. We sure did. We want to thank you for coming and we encourage you to please follow us on Twitter. We've also put all of the code, including a working Kubernetes pipeline for all the different modules, on GitHub. Be sure to check that out as well.
To the code cave, Robin.